This is a video for how to create a motion graph from your Automata box designs within Autodesk Inventor. You'll notice that on my screen in Inventor, I have an Automata box that has a eccentric cam over here on the left-hand side, and then I have another assembly over here on the right that has a hexagon cam. And after constraining your follower and your cam and your crank, you're going to notice that you can get a ruler and put a ruler on the side of the box. So when we go to the side of the box and take a look, we can actually rotate our cam, and you can see that that follower, which is this thing right here, is going to follow the cam as you rotate the axle or the crank, whatever you wish to call it. So as we rotate around, we're going to notice that we are going to get the different heights of displacement along this ruler. So we could say at 0 degrees, it looks like we are right at about 3 and let's say 5/8 of an inch, maybe something like that, or even we might say 3 3/4. Maybe 3 3/4 is better. So we could say that. So as we look through, we could say 3.75 is at 0, and as we go around at different angles, once we get over here, let's say to 90, we can notice that the follower is dropped down to 3 3/8. Somewhere around there. We could draw lines across, but the main point is that as you go through, you'll notice that as you rotate to, let's say, 180, we're getting down to more to 3 1/4, and you need to take down displacement values as you rotate around a 360-degree axis. It would be the same thing over here for the hexagon cam. You'll notice that the hexagon cam is more, let's say, pulsating as it goes than the eccentric cam. This eccentric cam is much more of, let's say, an oblong cam that is much more going to be in the idea of a normally distributed curve. It's going to be really wide and tall as we go through and use it. This one's going to be more of a heartbeat type of a line that we're going to see on our chart that we are going to create. So after you go through and find your data, you are going to place the data. So I had a left cam and a right cam. We could call this the eccentric cam, or we could call this the hexagon cam. And you need to make sure you record your data. So a basic angle of rotation in degrees, you'll see is 0 through 360. We did 45-degree measurements. You can go through again and go back to Inventor, and you can take your measurements. Now, as you design your cam in Inventor, you want to make sure that it is going to be accomplishing the task that you wish for the Automata box to accomplish. So these are measurements that you want to take as you go through and design an Inventor before you, let's say, go to the box and actually design the box. That's what's going to help you take these measurements and find out the exact heights as you design your cams to accomplish the task you wish for the box to accomplish. So in order to create our charts, we are going to go highlight all of our data, including our titles. And you're going to go to Insert, and we are going to go to a scatter plot. And we're going to find the scatter plot with smooth lines. And we're going to click. And you're going to notice that we have for ourselves a chart in here. Down at the bottom, you can see the left cam and the right cam. Now, over here on the left-hand side, this went all the way down to 0. And you'll notice that our smallest displacement value that we have over here is actually 1.25. I don't see any value lesser than 1.25. We would like to make our bottom value over here to be our smallest amount. So we're going to click on the chart. And over here on the side, if I right click and I go to editing the data of the chart. So I'm going to go to select data. Don't want to get out of that. You can double click, excuse me. You tap on this part and all you have to do is just double click, excuse me. Just double click and come over here on the right to axis options. And we're going to go to axis options, and you're going to notice the minimum that they have is 0. We want our minimum to be 1.25. So I'm going to go 1.25 and hit enter. And you're going to notice now it's going to drop this all the way down here to the bottom. Now, the axis down here on the bottom for our angular dimensions goes all the way to 400. We don't have a 400-degree axis. So just tap down here on the bottom, and you're going to notice we're going to go back to axis options. And it says the maximum is 400. We want that to be 360. And hit enter. And it's going to make this -40. That's ridiculous. We're just going to highlight that, and we're going to say 0 and just tap outside of it. And you now have yourself your chart. You can notice how the the tan or orange line here is a little bit more pulsating, just like our hexagon cam. You can notice that the left cam here for vertical displacement, this would be more like the eccentric cam. You know, it kind of rolls up and then rolls down. So the chart title at the top is going to be vertical displacement in inches. So we're going to say vertical displacement inches versus angle in degrees. And that is your chart. So one thing we can do is once you decide which cams you're going to use for your Automata box, you can then predict accurately via the charts exactly what's going to happen as you rotate that crank those degrees. And so this is what ultimately is going to drive the final design of your cams, be it 3D printing, laser cutting them out with an X-Acto knife. This is what's going to ultimately drive your design of what's going to happen in your actual cams. Because if we look at it, in an isometric view, we can actually see, let's zoom out a little bit, so you actually see that follower going up and down. We now know exactly where it's going to be at every angle of rotation. Same thing over here for the eccentric cam. You're going to notice that that is a much more drawn out motion. It's not pulsating. It's not like a heartbeat graph. It is much more up and down, exactly like we see on our chart here. So it's pretty obvious that we could go in and change this and call this our eccentric cam, and this one is going to be more of our hexagon cam. So you can actually see what's going to happen between the two of them and exactly what's going to be going on at each point along your rotation. So again, down here at the bottom, we could come in here and say, I want you to change the axis along the bottom. I want the major units to be in degrees of 15. And we could change this to 15 and 30 and 45 degrees and 60 degrees, and you can see exactly where this is going to be at every 15-degree increment, and we could go along the X and the Y axis. The point of this chart, again, is to drive the design of the cams. So it's not like, well, we made the cams and threw them in there. We can go back and change the diameter of the eccentric cam. We can go in and change the hexagon values and change that to drive the design of where we want our cams to be. So if we wanted to actually go back and make, let's say, this hexagon smaller, or we want to go back and change its diameter to be larger because we want the displacement at the top to be at a different point, we can go back and redesign that. But you're designing based upon the data that you're getting from your chart, from the data that you're taking. So this has been a video on how to go about creating a chart from the displacement values obtained through using your Automata box assembly in Autodesk Inventor.